All right, let's talk about one of the trickiest subjects in all of software, concurrency. Today, we're doing a deep dive into Chapter 13 of a book that's probably on your shelf right now, so let's just get straight into it. Yep, we're pulling our insights from Robert C. Martin's Clean Code. You know, this book isn't just about theory. It's really a guide to professionalism, to true software craftsmanship. And as we're about to see, when you're dealing with concurrency, that level of craftsmanship is absolutely non-negotiable.
So why even bother with something so notoriously difficult? Well, this quote from the book gets right to the heart of it. Concurrency is a decoupling strategy. It lets us separate what gets done from when it gets done. And that one idea, that single concept, is the key to unlocking better performance, responsiveness, and even a better overall design for your application.
So here's our game plan. We're going to start with that core idea, the power of concurrency. Then, we're walking straight into the minefield of all its hidden dangers. After that, we'll arm ourselves with some solid defense principles, look at a few classic patterns, and finally, we'll talk about how to actually find these bugs that seem designed to hide from you.
Okay, let's really dig into that foundational idea. The whole reason to use concurrency, its real power, comes from this amazing ability to separate a task, the what, from the specific moment it gets executed, the when. Think about it. In a single-threaded world, the what and the when are just completely locked together. But when you decouple them, your system starts to feel less like one giant, clunky loop and more like a whole set of tiny, collaborating programs. This doesn't just make things feel faster, it can actually make the whole system easier to understand. That is, if you do it right.
And that is a very, very big if. Because while concurrency is incredibly powerful, it is a minefield. It's just littered with traps for anyone who's not paying attention, with subtle dangers that can completely blow up your application when you least expect it. And these right here, these are some of the most dangerous myths a developer can fall for. The idea that it's some magic performance boost, it's not. That you can just sprinkle it onto an existing design, you absolutely cannot. That your container or framework is just going to save you, it won't. And maybe the most dangerous one of all, that those bizarre, impossible to reproduce bugs are just flukes or cosmic rays. No, they're real and they're waiting for you.
Now take a look at this little piece of code. It looks totally harmless, doesn't it? I mean, it's one line inside one method. What could possibly go wrong if two different threads call getNextID at pretty much the same time?
Well, here is the hidden danger. You expect two threads to call the method and get two different IDs back, right? 43 and 44. But that little increment operation, that plus, it's not atomic. That means it isn't one single uninterruptible operation. So thread 1 can read the value, but before it can write the new value back, it gets interrupted. Then thread 2 comes in and reads the exact same old value. The result? They both end up with ID 43, an increment just vanishes into thin air, and now your data is silently corrupted. That's a classic race condition. Still think it's a simple line of code? Brace yourself. For just two threads running through that one line of Java, there are, and this is not a typo, 12,870 different possible execution paths. Most of them work just fine, but some of them don't. And this just perfectly illustrates the insane scale of the problem. You can't possibly test your way out of this by just hoping for the best. So, how do we even begin to navigate this minefield? We need a professional's toolkit. We need a set of defense principles that help us write concurrent code that is correct by design, not by accident. Your first and most important line of defense is a principle you already know and love, the single responsibility principle. The logic here is just crystal clear. Concurrency is so hard, it deserves to be a responsibility all by itself. So you need to keep your concurrency code separate from your business logic. Isolate it, protect it, give it its own space. And building on that principle, here are three really powerful tactics. First, limit the scope of any data that has to be shared. Seriously, think of it like a crime scene. The smaller it is, the easier it is to control. Second, and this is even better, just avoid sharing data altogether by giving each thread its own unchangeable copy. And third, try to design your tasks so that threads are as independent as possible, each one just happily working away in its own little world. Now the good news is, you're not the first developer to fight these battles. A lot of concurrency challenges actually fall into these well-understood patterns, or what we call execution models. And if you know them, you can spot and solve problems way faster. Here are three of the big ones. The producer-consumer model is perfect for when some threads are creating work, like, say, incoming web requests, and other threads are processing that work. The main challenge there is just managing that shared to-do list. Then you've got the reader's-writer's model.
This is great when you have tons of threads reading data, but only a few that ever need to write to it. The goal is to let all the readers go at once, but make sure a writer can get exclusive access when it needs it. And finally, the dining philosophers. It's this classic analogy for when you have multiple threads all competing for a limited pool of resources, like database connections. The big danger here is deadlock, where everyone is waiting for everyone else, and the whole system just grinds to a halt. Recognizing which pattern you're in gives you a huge head start.
But, even with a perfect design, you still have to test. And testing concurrent code is its own special kind of headache. Because how do you reliably find bugs that are, by their very nature, completely unreliable?
This is the question that keeps developers up at night, right? It's that bug that only shows up on the production server, under heavy load when there's a full moon. How do you catch a ghost? The answer is you have to completely change your mindset about what testing even means.
A professional adopts a disciplined approach. First, never ever dismiss a failure as a one-off or a glitch. It's a bug. Find it. Second, get your core logic working perfectly in a single thread before you even think about adding concurrency. Make your threading strategy pluggable so you can swap it in and out, and make it tunable so you can crank up the stress. And here's a great tip. Force the system to swap tasks like crazy by running with way more threads than you have processors. Now for one of my absolute favorite techniques from the book, jiggling. I know, it sounds funny, but the idea is brilliant. You deliberately mess with your code's execution order. You know you can't test all 12,870 paths, so you intentionally sprinkle in these tiny random delays using calls like sleep or yield. This jiggles the order of operations and dramatically increases the odds that a hidden flaw will finally pop up where you can actually see it and fix it.
And it can be as simple as this. You create a little method like jiggle it, and you just call it in your code at critical spots. During your testing phase, this method introduces those small random delays. But in production, it does absolutely nothing. It is such a simple, powerful way to force those hidden race conditions and deadlocks out into the open.
So if you only remember 3 things from all this, let it be these. 1. Separate your concurrency concerns from everything else. 2. Minimize the amount of data you share. The less you share, the fewer problems you have. And 3. Treat testing not as an afterthought, but as a deliberate, aggressive discipline to hunt down failures.
And that really brings us to the final thought. Writing clean, correct, concurrent code isn't just a technical skill, it's a mark of true professionalism. It takes discipline, it takes rigor, and it takes a real commitment to craftsmanship. So the question to ask yourself isn't just, does my code work most of the time, but is my code truly professional?